Assalamualaikum everybody, we are from group CDCS145C. This video presentation is for course subject MAT300. We are going to talk about application of first order differential equation for electric circuit under RL circuit. So before we begin, I'll be introducing our group members. The first group member is me, Danish Irwan bin Muhammad Azrul. The second group member is Muhammad Nur Haziq bin Muhammad Jamali. And the third and final group member is Azim Shazmin bin Shahri.
Before we go to more deeper about this presentation, we need to know the learning of content. So first we have introduction, problem statement, problem solution, followed by conclusion, and lastly references. So the first part is introduction. An electric circuit is a closed loop through which an electric current can flow. It consists of various components such as resistor, capacitor, inductor, and voltage sources, interconnected by conductive pathways. Circuit analysis involves applying mathematical principle and technique to determine the electrical quantity within a circuit. These include calculating voltage, current, and power dissipation, as well as understanding the relation between these variables. Key mathematical concepts used in circuit analysis includes Ohm's law, Kirchhoff's law, and various circuit theorems such as the superposition theorem, Thevenin theorem, and Norton theorem. So let's proceed to another part, which is RL circuit. It consists of a resistor with a resistance of R ohms and an inductor with an inductance of L Henry. An electric motive force from a battery or generator produce a voltage ET volts and a current of IT ampere of A at time t. According to Kirchhoff's second law, the sum of the voltage drop across the inductor VL and the voltage drop the resistor VR equal to the impressed voltage ET. So the formula is VL plus VR equal to ET. The drop in voltage due to the resistor is given by RL, and the voltage drop across the inductor is L times dI over dt. So the formula is L times dI over dt plus Ri equal to ET.
Okay, now we proceed to the problem statement. Suppose that in the simple circuit, the resistance given is 5 ohm and the inductance is 0.4 H. If a battery gives a constant current of 50 sin 20t V and the switch is closed when t equals to 0, so the current starts with I0 equals to 0. Find the current after 1 second and the limiting value of the current. Okay, so for the first step to solve the equation is first to list out all the information that we have been given. After that, the second step is to substitute the information given into the RL circuit formula. Hence, we will get 0.4 di over dt plus 5i equals to 50 sin 20t. To solve this equation, first we need to transform it into a standard form, which we will get di over dt plus 12.5i equals to 125 sin 20t. So the next step is to find the IF integrating factor, which we will get IF equals to e power of 12.5t. The next step is to multiply the integrating factor with both sides. After that, we can simplify it, hence we will get the simplified version which is e power of 12.5t I equals to integration of 1 to 5 sin 20t e power of 12.5t. So next, we can find the answer for integration of e power of 12.5t times sin 20t dt by using IBP formula, which in the end we will get e power of 12.5t sin 20t minus integration of 20 cos 20t e power of 12.5t. From there, we can just simplify it, which we will get e power of 12.5t over 12.5 sine 20t minus 8 over 5 integration of e power of 12.5t cos 20t. So from there, we need to do another IBP. So we will get the result of the IBP, which is 1 over 12.5 e power of 12.5t sine 20t minus 8 over 5 times e power of 12.5t cos 20t over 12.5 minus integration of negative 20 sine 20t e power of 12.5t over 12.5. So from there, we can see there is a similar constraint. What we can do is to transfer the constraint from the right hand side into the left hand side, and then from there we can just simplify the left hand side, which we will get 89 over 35 times integration of e power 12.5t sine 20 equals to 1 over 12.5 e power 12.5t sine 20t minus 16 over 125 e power 12.5t cos 20t. So from there, we can find the answer for the integration is 2 over 89 times e power 12.5t sine 20t minus 16 over 445 times e power of 12.5t cos 20t. After we find the solution for the integration, we can just substitute it back into the equation, into the original equation, and then just expand it and then simplify it again until we will get IT is equal to 50 over 89 times 5 sine 20t minus 8 cos 20t plus c e power of negative 12.5t. So from there, the final step, we need to find the value of c. We can use the initial condition, which is I0 equals to 0, and then substitute it into the equation to find c. After the calculation, we'll find out that the c is equals to 400 over 89. So just substitute back the value of c into the original equation. We will get IT is equals to 50 over 89 times 5 sine 20t minus 8 cos 20t plus 400 over 89 times e power of negative 12.5t. So from there, we can solve the first problem, which is to find the current after 1 second, which is simple. All we need to do is just substitute the value 1 into the equation. So we got 50 over 89 times 5 sine 20 times 1 minus 8 cos 20 times 1 plus 400 over 89 times e power of 12.5 times 1. By solving that, we will get the final answer, which is the current after 1 second is equals to 0.73A or 0.73 ampere.
For the second question, we want to find the limiting value of the current as time t approaches infinity. So we start with the expression for the current IT. We add the limit t approaches infinity to the equation. Next, as you can see here, we split the limit into two separate limits. Then we observing the behavior of the exponential term. The exponential term is e to the power of negative 17.5t decreases rapidly to 0 as t approaches infinity because the exponent is negative. So it will become 0. Lastly, we focus on the trigonometric term. Since the trigo term does not depends on exponentially decaying factor, it remains constant. Therefore, as t goes to infinity, the limiting value of the current is 50 over 89 sine 20t minus 8 cos 20t amperes. In conclusion, in this project, we explored the behavior of an RL circuit powered by an alternating voltage source. Using linear differential equations, we analyze how the current evolves over time, starting from 0 and approaching a limiting value. This analysis highlights the importance of understanding transient and steady-state behavior in electrical circuits.
Such knowledge is crucial for designing and optimizing circuits in real-world applications. Overall, this project allowed us to apply theoretical concepts to solve practical problems, reinforcing our understanding of circuit analysis and the role of mathematical modeling in engineering. So this is our references of our presentation, which is the module and the sound for the background. Thank you for watching our presentation. I hope this explanation was clear and helpful.